Hello world, it's Steven with Work on the 21st. In this video I'm going to demystify artificial intelligence, talk about the difference between AI and machine learning, and go over some of the math involved in data science. But don't worry, if you live through grade 10 calculus, you'll be able to get through this stuff no problem. So, first of all, is machine learning just a synonym for AI? Kind of. Machine learning is the verb, and AI is the noun. A computer that is intelligent and can accurately make predictions has artificial intelligence, but in order to gain intelligence, it has to do some machine learning. So when you're talking about AI and trying to impress your boss, say things like, we will use AI to determine the cost of X, and we will use machine learning to create a model that can predict Y. Okay, awesome. Next up, let's look at how machine learning takes place. We're going to go through something called linear regression. Wait, don't go anywhere, it's not as bad as it sounds. Linear regression in its simplest form is just plotting points on a scatter plot and drawing a line through it. Sounds easy enough, right? Here's a scatter plot. Here's that same scatter plot with a line through it. To draw this, we need to unrepress some of our memories from high school calculus. Remember y equals mx plus b? If not, don't worry about it, we'll go through it. This just gives us a straight line between 2 points. The m and the b are the two variables that we get to play around with to come up with the best line possible. So, looking at this current model, if you give me any x value, I can tell you with some accuracy where y will be. Seems simple enough, but where it breaks down is when you want to do this with hundreds of thousands of data points, with multiple variables. Furthermore, how do we accurately draw that line in the first place? And how do we test to see if our model that we've drawn is even accurate enough to predict things with any degree of certainty? This is where we tap into the second intimidating term in this video, gradient descent. Let's take a look at this equation. Yes, it's ugly. No, you don't need to know what the Greek E means or what Poseidon's trident represents. What you need to know is that this is just one of many equations that we can run to test the accuracy of our model. We call it loss. So, we run that equation, which spits out a graph like this. Now what we need to do is adjust our weight to get the lowest loss possible. We do this by stepping through different weight values until we hit the absolute smallest loss value. Basically, we come up with a way for a machine to step through all of those thousands of data points until it hits the bottom. Think of the game kids play when they hide something from a friend and then yell hotter or colder as they move closer or further from the item. Google has a good example of this. You see here we have a variable called the learning rate. We need to find the optimal learning rate to find the lowest loss of our function so that we can efficiently measure the accuracy of our model. Remember, the biggest thing with AI is that we're dealing with amazingly huge data sets. So doing something slower than it has to be done costs time and money. Setting the wrong learning rate could be the difference between minutes, hours, days, or even months. And this is just one small part of the machine learning process. So let's try to find the best learning rate for this model. A learning rate that's too small will take forever to get to the bottom. A learning rate that's too high will bounce around aimlessly all over the place. Grabbing the middle number won't help either. The optimal learning rate is different for every model. But determining the best learning rate doesn't mean that we're done. All that's done is tell us how accurate our initial model is. Now we need to go back and tweak our model. Remember y equals mx plus b? We need to get different m values for each two data points. Then we test its loss again and keep going, over and over and over again until we find our highest level of accuracy. The worst part? Sometimes we do that for a couple weeks only to find out that the accuracy is too low and that those two variables can't be used to accurately predict one another. Sounds fun, right? Now maybe all those booming jobs in AI, machine learning, and data science seem a little less sexy. So, that's linear regression and gradient descent in a nutshell. But that's just one method of machine learning. There's so many more, and they all contain ridiculous math. The best way to think of machine learning is that it's just math. Math that we've had and known about for about 100 years. The difference is that now we have the right mix of computing power and data to be able to create models that are highly accurate and can run in a relatively short period of time. Doing machine learning by hand would take hundreds of years. Computers can do it in seconds. Thanks for watching, and I hope you enjoyed this episode of Work on the 21st. If you have any questions about machine learning, AI, and its applicability to your business, please leave a comment or send me a message.